Welcome to the FLC Lab Showcase. And today you have the Coast Guard's Research and Development Center located in the Coast Guard city of New London, Connecticut. My name is Bert Massesker, and I'm the civilian director here at the lab. The R&D Center is located in the Fort Trumbull area next to Station New London. And across the river, the Thames River, is Electric Boat Division of General Dynamics. And we are line of sight to where the future National Coast Guard Museum is going. And if you paddle upriver a little bit, you'll bump into the Naval Submarine Base in Groton, as well as the Coast Guard Academy. So that's where we are. A little brief of what we do. We are the only facility in the Coast Guard that receives a very modest appropriation for doing research in support of the Coast Guard's major role in maritime security, safety, and stewardship. We support all 11 statutory missions in the Coast Guard with a portfolio of projects that we execute, typically 50 to 60 projects on any given year. When you come to visit us, you're going to see that we are not necessarily a bunch of folks running around in white lab coats. We in doing very basic research, 6'1", 6'2" kind of research, but we are a professional team, a workforce of military and civilian scientists and engineers that work very closely together. We work with our program offices and we work with operators at Coast Guard headquarters to reduce the risk and raise the value of introducing new technology into the Coast Guard. We're about 82 strong in our laboratory. We do have a facility. We have some lab and demonstration spaces. However, the field is really our primary lab space. And we make very heavy use of requests for forces in order to, and our good relations, of course, with the operational commanders, to conduct test and evaluation and evaluate new technology. So I'm going to just take a quick moment to explain what we mean by technology tension. This tension that I'm talking about is a healthy tension that's involved with the action and reaction forces acting upon the organizational positioning of that best combination of technology as well as human performance in support of Coast Guard missions. So an example, I'll take the evolution of apes to navigation, where we've gone from manned to unmanned lightships and lighthouses, and the buoys that we have in our waterways, from having no power to power, and then changing over from battery power to more environmentally friendly solar powering of our lanterns. And at the same time, other shifts took place in the past where we have shifted from the high maintenance incandescent bulbs to high efficiency LED. So this is an example of the combination of technology that has transformed and how we light our waterways today. Another great example would be some past history of the Coast Guard in terms of its significant investment in land-based Loran-C radio navigation technology, which has been made obsolete by space-based GPS. None of these transformations have happened overnight. And even though a lot of these technologies may on the surface appear very attractive for immediate adoption because of that promise of increased performance and increased efficiency, the reality is that it takes many, many years to implement. And that is because there are these technology tensions. These tensions include the trust and the acceptance of the technology, where the market and the innovation ecosystems are in supporting the technologies as well as advancing these new technologies. Sometimes it's our own institutional inertia that we have to overcome, the cultural aspect of things. And certainly there needs to be the recapitalization resources in order to make that tangible shift. So enough of that. I'm going to pause here and do a quick shout out and thank you to FLC, to Beth and her team for setting up this webinar so that we can give you a glimpse into our world of work and into a couple of technology tensions that will be transforming mission execution in the future. So with that, Beth is going to flip to a video that is going to showcase a little bit of what we do, and then we're going to launch right into the first panel discussion. So thank you, enjoy.
Hello, I am Christine Hansen, and I will be moderating the discussion around the physical and virtual navigation technology. Before we start, I'm going to take a tiny step back and let me frame it for you a little bit. NOAA reports that 76% of all trade, US trade, travels using some form of marine transportation, and that number jumps to 90 when we talk about international trade. So the Coast Guard is responsible for safeguarding our marine transportation system and the ATON that are part of that safety net. And I just said the word ATON, and it's the shortened form of aids to navigation. You're going to hear that through the discussion. But let's go over to our subject matter experts over here. I have with me, I have James Spilsbury from our Waterway branch, and I have Lieutenant Commander John Porster with our Information Technology Group. And James, can you kick us off, please?
Thank you, Christine, and thank you everyone for joining us today. Good afternoon. My name is James Spilsbury. I'm a physical scientist here at the Research and Development Center for about 2 years now. I'm currently the project manager on our next generation aids navigation buoy project. Prior to that, I've done a lot of work with NOAA and in industry, and actually served as a licensed boat captain. So it's a kind of a perspective I like to incorporate into our project here, is since this is a very public-facing, mariner-driven mission. So kind of building on what Christine kind of introduced us with, there's many types of ATON, aids navigation, but this focus will be on buoys, as that's really what RDC is working on at the moment. So ATON is generally used to mark the safe navigation channels throughout the US, and as well as marine hazards. Buoys and other ATON structures are kind of analogous to the lines and the signs that you would find on our roads. And the Coast Guard has traditionally used a steel-based buoy design for these structures. It may feature additional signaling equipment, such as a lantern, like the one you see here, as well as sound equipment, such as bells, whistles. And these designs have mostly remained unchanged for decades. So to kind of give you an idea of the scope of the network, our constellation and currently includes more than 10,000 aids in the coastal area and another 15,000 in our inland river systems, such as the Mississippi. And to maintain the system, we have a significant buoy tending capability, as well as shoreside assets to provide the logistics for the system. Buoy tending itself is a highly specialized and inherently dangerous operation, moving heavy loads in dynamic conditions. So our personnel are widely regarded as experts around the world in this area. So some of the challenges that the ATON program has, and why RDC is working on it, is steel buoys in the marine environment are, as you can imagine, highly corrosive, which is capital intensive from a maintenance perspective. Buoys are routinely subject to corrosion that causes holes, sinking, vessel strikes, as well as things like vandalism, gunshots. So RDC's project is really focused on taking a look at new commercial designs that are out there that may allow us to do business more efficiently, as well as have the Coast Guard be able to adapt ATON to new emerging needs, such as unmanned systems, which we'll hear from with our next panel. So when I refer to next generation buoys, I'm really talking about commercially available plastic, foam, and other hybrid type designs, such as plastic and metal. And this technology has been widely adopted by other Coast Guards internationally for cost savings and reduced maintenance. So the goal is really to evaluate where the US Coast Guard might be able to leverage this technology in our network. And we're currently in the midst of performing a field demonstration to see if the technology lives up to the challenge. So with that, just a brief kind of discussion of this lantern in front of us. So as Bert talked about in the introduction, one of the big evolutions in the ATON system has been the heavy use of LED lanterns. So we've moved from these pretty intense power systems to supply light for buoys, for example, to these fairly compact LED chassis that allow us to do business more efficiently and get more life cycle out of our lanterns. So this one actually features AIS integration, which I will hand off to John here.
Thanks, James. John, would you pick up? That's exciting right here.
Absolutely. So
Nothing like toys, right?
first, a little bit about myself. Lieutenant Commander John Porster. I'm an active duty officer stationed here at the Research and Development Center. I have a master's in IT management from the University of Ohio, and I also hold an MBA in acquisition systems from the Naval Postgraduate School. I'm a C5I officer, so I work mainly on IT projects when I'm not underway. So my other job in the Coast Guard has been sea duty. I've been to sea for 7 years total at this point. And now I'm at this land duty, which is a nice break from that high op tempo. So now a little bit of background. I'm currently working on the next generation of AIS, which stands for VHF Data Exchange System. And this is VDES is essentially the natural progression of AIS. So, James mentioned that this would actually be affixed to the top of a buoy, this light here, and it actually has an AIS beacon inside of it. So what is AIS? At its core, AIS is a maritime situational awareness tool that many mariners have adopted. Over 200,000 vessels have adopted AIS since the early 2000s. So what AIS does is it uses VHF frequencies to kind of transmit information about a ship's position, course, and speed, so that other vessels are more aware of their surroundings and understand, what they might be seeing, out their windows when they're looking about, or if they're in a low light situation or low visibility situation, they might be able to figure out what kind of situation they're getting themselves into. So it's probably saved countless lives just having that capability. And the Research and Development Center here at the Coast Guard has a long history of working with AIS and doing research to better understand its capabilities and how we can adopt this technology. And this is a great example of how we are currently integrating AIS into our ATON system. And basically the type of virtual aids that currently exist in the Coast Guard, we've got physical aids such as this one that actually transmit AIS information so that the mariner knows, hey, there's a buoy coming up here, so I should be on the lookout for that and try to avoid hitting it. And then the other one would be, completely virtual AIS ATON, which would be from a land station. You'd actually broadcast information about, the best channel. And so in that situation, there is no physical buoy, but we've replaced that physical buoy with a virtual ATON that actually just shows up on their electronic charting system. So there's some integration between AIS systems and modern electronic charting navigation systems.
Boy, I feel like I really have a good sense of where we are right now, but paint me a picture. What does 10 years from now look like? How are we helping to move the Coast Guard further down the line?
Yeah, I can jump in there. So I think that one important thing I want to emphasize is that both these technologies have kind of a symbiotic nature with themselves and equally play an important role in the modern maritime transportation system. So a lot of times our headquarters sponsors for these projects refer to this effort as waterways harmonization, which is really the convergence of kind of our traditional and new technologies to be the most effective for the modern mariner. So a downfall of physical ATON is that it takes time and money to replace and repair, especially if it's damaged or something changes about channel. So I think that's an example of where virtual AIS is a huge benefit to the system. I see over the next 5 to 10 years, continuing to make improvements to our ATON infrastructure with more efficient and resilient materials to the environment. Kind of addressing some of the issues I noted before that we've traditionally experienced with sinking and corrosion. And I think really using virtual elements to augment the system to fill traditional gaps. So after storms, when we lose a large percentage of our aids, as well as particular locations that are very difficult to put a buoy or a piling structure there, I think would be a great fit for virtual.
Yeah, and I talked a bit about VDES being the natural progression of AIS. AIS does have its limitations, and we're kind of coming up on that. It's been so widely adopted that in many well-trafficked areas, you've got a lot of congestion in the current VHF spectrum. So signals are getting stepped on basically and lost, and so
victim of its own success.
Exactly, and we're really VDES is the hope for VDES, and it's still a standard that's in development in the international community. The hope for VDES is that it's going to open up more channels, which will allow innovation, higher bit rates, so it might allow the transfer of data, and the next 5 to 10 years could be really exciting. They're already coming online with VDES capable units for that mariners can go out and purchase, and those are supposed to be forwards and backwards compatible with the current AIS system. So it's really the natural progression of AIS, and I think that what we're going to see some really innovative things hopefully in the next few years with people trying to come up with new ways of using the system. You have embedded cybersecurity capabilities. There's a more robust satellite component, and I think that it's going to be very exciting to see what folks come up with and how we can leverage VDES in the future.
Oh, so we have both these things going on. We have some exciting stuff going on physical, some exciting stuff going on virtual. What's the best possible combination? What do we see about that synergy?
Yeah, I can jump in there. So I think the key is finding that balance between risk mitigation and redundancy. So as a mariner, navigation is all about having multiple tools for situational awareness. So I guess a true test for me would be, given that one of my primary systems fails, can I safely navigate from point A to point B, given a basic understanding of the navigation system? So I think that's really a benchmark we're trying to achieve with this balance between the aids. It's really kind of balancing the needle between under capacity, which would be risky, versus over capacity, which is too costly. And then ultimately at the end of the day, getting mariner buy-in. So particularly being a very mariner-driven, customer-driven effort, establishing that feedback loop so that we can kind of progress this technology in a way that's comfortable for a wide mariner user base. So.
Yeah, that's something the Coast Guard does really well at. We're really good at soliciting that feedback from the mariner and taking those concerns into consideration, and then working with the maritime community to kind of find a best fit. And that evolves over time as the mariners' needs change and as technology improves and people become more comfortable with that technology. Then you can start to see the adoption of things like AIS. So I think that James really hit on like the service level that we're trying to provide the mariner, and at the same time we're trying to be good stewards of the taxpayers' dollars. So yeah, it will be interesting to see how the ATON system evolves over the next few years.
Yeah, okay, but what I really want to know from like an average person standpoint, are we going to have like a Waze for the mariner? Are we going to have this real-time update on what's going on out in the water like we can when we're just driving around now?
Yeah, I was just having a conversation about this the other day. So we are really interested in how we can transmit data to mariners in kind of a live action way. And one of the things I want to delve into in this project is really being able to transport files that are way too big for normal AIS traffic over these new VDES channels, and allow mariners to receive information about en route weather or ice maps that could be vital, especially in areas like the Arctic, which we're seeing a lot more traffic in, and we expect even more in the coming years. So I think that being able to transmit that information, perhaps even over low Earth orbit satellite link that's VDES capable, would be a huge game changer in that realm, for sure.
That'd be exciting for the mariner, wouldn't it, James?
Yeah, I agree. Admittedly, with physical ATON, we're kind of constrained by the time and money aspect of how quickly we can respond to discrepancies. So yeah, I think that the real-time idea sounds very intriguing.
Okay, well, so let's get some closing thoughts. What does this all mean, and how does it kind of fit into the RDC's value statement?
Yeah, I think what we really want from the RDC is to understand what is in the realm of the possible, and how we could leverage this information to make better decisions at the higher levels of the Coast Guard, to be strategic thinking and to kind of understand what's coming down the line here. So and I look at, from a resiliency of our maritime transportation system, I see a lot of potential with technologies like VDES. We have a lot of storms that will blow through the Gulf of Mexico and the Western rivers, and channels will shift. And we want to get the mariners back up and running and the economy moving again as soon as possible. So as soon as we can get the information about, if the channel is still safe or if it's shifted in some direction, the sooner we can get that information out to the mariners, the faster we can recover from the storm. So I think there's a lot of potential in the future.
Yeah, I agree wholeheartedly. I think it's about seeing where this technology fits in with the strategic vision for the Coast Guard, and how it can help modernize the system to adapt to future mariners' needs, such as unmanned boating.
Oh, what a lovely segue.
Perfect segue.
All right. Thanks, Christine. Pretty interesting conversation. My name is Jason Story. I'm a research engineer here at the R&D Center. I'll be moderating a discussion today on technology tensions associated with the introduction of unmanned systems in the Coast Guard. I'm going to be joining this conversation with Lieutenant Dean Gilbert, who is a project manager in the surface branch, and his primary career specialty is in operations afloat. Also with Mr. Derek Meyer, he's a mechanical engineer and a project manager also in the surface branch, who focuses primarily on unmanned systems. To start with, Derek, could you give us kind of a quick example of some of the mission areas where unmanned systems are being used in the Coast Guard?
Absolutely. So good afternoon, everyone. So here, especially at our Research and Development Center, we've been studying a variety of unmanned systems. Today, I think we're going to mostly talk about either optionally manned systems, which are unmanned surface vessels, which can be operated either with a crew aboard or with no one aboard, or completely unmanned systems that have no infrastructure for personnel to be on board and are only capable of being operated remotely. So some of our most recent work, we performed a maritime domain awareness pilot study. It was last year with these long endurance craft. We've also performed several swarm autonomy missions, demonstrating the capability for these systems to escort a high value asset while underway. So from this research, we really seen that the USVs have the capability to serve in pretty much any mission set that requires information surveillance and reconnaissance primarily, amongst other missions.
Thanks, Derek. So Dean, now that we have an idea of some of the missions, where are some of the technology tensions arising from this?
So I'd say a lot of tension comes from a fear of over-reliance on technology and developing complacency in our operators, applicability with the unmanned systems to the actual missions of the Coast Guard, and then as well as just the costs that are associated with implementing unmanned systems in the Coast Guard.
Excellent. So Dean, you mentioned the cost of unmanned systems, and that's a very important topic for the Coast Guard with our always constrained budget. How is the cost of unmanned systems creating tension?
Sure. So first and foremost, the argument supporting cost benefit of unmanned systems on a larger scale is that fewer personnel equals fewer habitability requirements, fewer replenishments at sea, less costs associated with personnel training and incentive pays. But the bottom line up front is that sailors are not a cost burden. They are a necessary and organic part of the ship. Any unmanned piece of equipment is usually more complex than a manned machine assigned to do an equivalent task. This can make routine and corrective maintenance more costly, and also carries hidden costs by way of high-level training required to conduct the maintenance. Additionally, without sailors present on board ships to observe and learn from contractors who repair these complex systems, the maintenance costs are going to remain beholden to third-party contractors. Navy did a recent analysis of the Littoral Combat Ship Program and determined that reducing maintenance at the operator level simply increased it at the intermediate and original manufacturer levels. So in this case, the manning wasn't reduced; it was just transposed to the original equipment manufacturers, driving up costs. They concluded that until this equipment can learn on its own and repair itself, it's going to remain the case. Now, it's important to note that the littoral combat ships were completely unmanned, but minimally manned, with the goal to replace sailors for technology, which we can correlate completely to unmanned vessels.
Yeah, no, those are great points. So when you're looking at the cost of these systems, that's something that we're definitely studying currently. For the Coast Guard right now, most of our research is on kind of scaling down unmanned surface vessels to smaller craft. Just because the Coast Guard mission inherently does require personnel aboard a cutter. I don't really see unmanned cutters in the future. We need people to interdict and perform those particular missions. However, these smaller USVs offer us, especially if they're optionally manned, the ability to perform missions in either an unmanned or manned setting. And ideally, the purpose of a USV is to reduce the manning required to perform a certain mission. So if there's a dull, dirty, or dangerous mission to be performed, you could potentially have fewer crew, as one person's only required to operate this USV at a command and control station, while those other crew members can be performing additional tasks aboard the vessel. So that's something that definitely needs to be studied, and I think that the Coast Guard's at a good point where this technology is definitely advanced enough where we can take a serious look at it. In addition to this, integrating these systems, especially in today's marketplace with technology, a lot of vessels come already with fly-by-wire electronics, which are easily capable of being hooked up to these autonomy computers. Which having that, having an existing vessel and hooking up one of these autonomy computers to it with the existing fly-by-wire controls really lowers the cost, to enter this marketplace. So kind of overall, we really need to do more research and determine what the cost benefit is, but also the risk. If there's a dangerous mission that we need to be performing that doesn't require the crew on board, you could definitely reduce the risk of having those operators out there by having an operator as an unmanned vessel.
Excellent. Another topic for discussion would be that the Coast Guard operators are known for their expert level of seamanship and regularly conduct some pretty difficult evolutions at sea, and things like docking, stern launch and recovery, as well as station keeping. Derek, you think unmanned systems are capable of conducting these complex missions?
So those are definitely some difficult boat maneuvers. It's definitely beneficial to have operator on board. However, when you look at operating these vessels, a lot of them offer the capability of remote control operation. It swaps between remote control and autonomy. So you can essentially take the helm of one of these vessels and put it aboard the cutter. And when you don't want to operate one of these vessels autonomously to perform these difficult maneuvers, let's say launch and recovery, on a stern ramp of a cutter, you could have a coxswain theoretically drive it up the ramp just as they would normally. For certain operations like launching and recovering via a davit, having somebody there to remove the rigging kind of eliminates the potential, at least currently, for that type of asset that needs to be delivered by a davit to be operated. But taking that in addition to during autonomous operations, for example, station keeping, having a USV that's capable of station keeping, they're definitely doing that currently. There's plenty of technologies out there capable of performing that mission. So I think that it isn't necessarily we can't necessarily perform all the missions, but we can definitely supplement certain missions with unmanned systems.
Yeah, that's a great point, Derek. I mean, proving that unmanned systems can do these difficult operations is not the issue. We've done, in just a small amount of time I've been here, we've done a lot of testing and with the systems and proven that they've been able to do so. But what really makes the operators great is really learning and analyzing and improving on these evolutions. You can moor to a pier 1,000 times, but each time it's going to be different. Main reason is the environmentals, the wind, waves, current, all that play a major factor into how an operator would change or modify their technique to execute these evolutions. Case in point, I was recently on a 175-foot buoy tender, driving up on a buoy, and they were using their dynamic positioning system, which is pretty much like an unmanned, piece of technology used to help them station keep alongside a buoy while they're, conducting operations. But because of the currents, because of the environmentals, that system was just unable to overcome. And so the crew, the operator had to flip into manual mode and change their technique and ploy to be able to drive on that buoy. So when we talk about optimally manned assets, I think that is the way forward, where we can build some of this synergy, as Ms. Hansen talked about, with manned and unmanned systems.
Okay, so diving a little bit further into that topic, one of the most important missions that the Coast Guard conducts is search and rescue. Dean, do you think that unmanned systems could affect a rescue of a person in the water?
I think that's completely situation dependent. If that person is conscious and strong enough to pull themselves up onto a boat, I mean we've demonstrated that our USVs can run search patterns, can integrate computer vision and locate persons in the water from greater than 300 meters out. But that situation changes if that person is unconscious or they're not strong enough, or maybe they've sustained an injury in the process that limits them from being able to climb into a vessel. So that's all. Those are all things that we need to really take a look at if we want to affect us our mission.
Yeah, I agree with you for those points. USVs can operate in a variety of mission sets. However, rescuing a person in the water, with an unmanned vessel is a difficult operation if the person's conscious and capable of getting on board, as you mentioned. Absolutely, but that's not always the case. If the person's unconscious or needs immediate aid, the USV isn't necessarily going to be able to pull them on board. At least not with today's technology. Now that doesn't mean that a USV can't be beneficial to a search and rescue mission. Let's say through computer vision they're able to locate the person. They can still deliver personal flotation device, life ring, or survival say like survival raft. So I think that there's ways especially if you have two vessels out there, one's an autonomous vessel doing a search pattern trying to locate a person, and it does locate a person. Having that vessel out there with the in combination with a manned asset that can cue the manned asset over to a person in the water would definitely be beneficial to future missions.
Great. So as a final topic that I'd like for us to discuss was unmanned systems not having a crew on board to monitor machinery and other systems, as well as the increased cybersecurity requirements to ensure the reliability of the systems. Is there any tension there, Dean?
Yes, and to answer your question, you're kind of breaking up into operations engineering. Talking about collision avoidance, I think that's one of the biggest concerns when we talk about unmanned vessels at sea is collision avoidance. And the fact of the matter is, in case of autonomy, it will be the result of an algorithm or artificial intelligence implemented on the vessel, and its reliability will depend on the level of sophistication of the system. And without a proper lookout, an autonomous ship needs to sense the environment and send information to shoreside in real time, or independently make that decision based on that. And the reliability and accuracy of sensors on board or communication system capabilities will limit the amount of information accessible at a particular moment of time for a decision-making and algorithm. Now, when we talk about monitoring of engineering systems, remote monitoring is a foundational element of operating unmanned assets. However, when we integrate the supervisory control and data acquisition or SCADA technology with data transfer mechanism, that is a complex and costly process. To take the military Sea Lift Command, they have proven to be able to do this, but with manned assets. They are able to transfer approximately 3 gigabytes of data from over 100 vessels per week to shore base systems with normally less than 12 hours of delay, which is amazing for its intended purpose, which is long-term trends analysis. But when we talk about critical engineering systems without in-person oversight, 12 hours of delay in response could end up with a vessel at the bottom of the ocean. And then Jason, you talked about cybersecurity concerns. I was reading a journal from the Marine Science and Engineering, and they argued that artificial intelligence programs, as they become more sophisticated, they will at the same time become more vulnerable to being hacked, and therefore pose greater security risks. These systems, with their that have so-called ethical governors, for instance, will have problems with framing and representation. And in order to manage such challenges, artificial intelligence software would be enormously complex, and complex software tends to have more software bugs, leading to more security vulnerabilities. Add that with very common threats of intentional GPS jamming, as well as AIS spoofing. These all pose serious concerns as we begin to invest in autonomous vessels.
Those are some great points. Reel back a little bit into the maintenance aboard a USV. That is a difficult topic to argue. Definitely performing on-demand maintenance on a unmanned vehicle is kind of the crux of the operation. However, having these machines with redundant systems or predictive maintenance, determining what your mission requirements are and what the predictive maintenance requirements are, you should be able to avoid some of these situations, and also know when to return to base. For example, additionally, having the vessel be able to perceive these operational parameters and understand when it's exceeding or could become damaged out at sea and return to base is also something that needs to be considered with these systems. For the privacy and cybersecurity aspect of these, the pipelines that we're looking at, cybersecurity needs to be robust. That's something that the Coast Guard, ensures on all their systems. But for cyber attacks, if you're in a GPS denied environment or somebody spoofing AIS, having secondary navigation systems that aren't dependent on those systems is also important for unmanned vessels, so you can at least navigate out of there. Computer vision also has other aspects to it where you can geolocate yourself if there's some type of feature in the area, which can be used for navigation too. So kind of overall, there are, those are definitely some obstacles that you brought up, but in the future, I think that they could be addressed through technology. And one last thing. So for the data transfer, that's something that's really going to require, for the requirements of these vessels to have more edge processing. So we know exactly what data we want to transmit when, to, reduce the amount of data that we're sending for our operators, but also the amount of time it takes to receive it based on the file sizes.
What a conversation, Dean and Derek. I appreciate all the insights in the unmanned systems, and where we left it, maybe our next group provide some insights on the new technology that maybe provide some solution to some of those issues.
Well, thanks, Jason. Great conversation there. Good afternoon, everyone. I'm Blair Swigart. I'm in the Modeling, Simulation, and Analysis branch here at the RDC, and I'm joined today by Christine Rusty Mahoney and Jared Peterson for a conversation about artificial intelligence and human-machine teaming. So quick intros, Jared holds a PhD in experimental psychology from Kansas State University. As a research psychologist here on staff, you've been with us for about 2 years now. Yep. And prior to coming, you were with the Army Research Institute.
Yep, that's correct.
Awesome. And Rusty, you kind of a long history in the Coast Guard Academy graduate, master's in industrial engineering, decision science from Wisconsin. You've taught at the Coast Guard Academy, and you've been here about 7 years now. And certainly are one of our AI and machine learning subject matter experts. So really thank you for joining the conversation here. I'd like to open this with a quote from Rear Admiral Brian Panoyer, who is the commander of the 11th Coast Guard District out in California. He recently said, "We have too much data coming in for humans to meaningfully process and monitor. We need to let computers do the heavy lifting so our personnel can focus on preparing, planning, and deploying force packages to incidents and targets." And when I hear that quote, it certainly seems to point to artificial intelligence. So Rusty, if you could give us kind of a brief overview of the technology and tell us what you and the teams are working on.
Okay, yeah, great. So I just want to start with a basic definition of what artificial intelligence is, because it's a little bit different to everybody. So here at the center, artificial intelligence is basically the ability for a computer to solve a problem that's usually addressed by humans because they require human intelligence or judgment. Some of the more popular examples of AI are going to be machine learning, natural language processing, speech recognition, and computer vision. So getting back to your original question, and specifically your quote from Admiral Panoyer about the heavy lifting is the RDC has employed used AI in several past and present projects to help our watchstanders improve their performance. So the first I'm going to talk about is a project titled Improved Efficiency in Domestic Inspections. This particular project applied deep learning to classify barges to determine which barges were most at risk for a deficiency upon inspection. The project used historical data collected on every single barge inspection in the past and trained an artificial neural net. The neural net was then fed data on upcoming barge inspections to determine their deficiency risk. So this project had the potential to improve inspection division efficiency in several ways. The first and most obvious was training. Training a marine inspector takes a while, so if you can get those inspectors on the barges that are going to have the most risk of a deficiency, they get better training and they do it in less time. The second way that this improved or could improve operations is the assignment of expertise. If you have a barge with a high probability of having some type of problem, we want to put someone on that barge that's going to find that problem. And so we can assign our inspectors, you know, based on, you don't want to put someone newly qualified who might accidentally overlook it. You're going to put somebody on there who's, you know, seen a lot and knows what to look for, and then maybe throw a couple more trainees on there as well and get, you know, more bang for your buck. And finally, prioritization of inspections. You never know when you're going to have a Deepwater Horizon oil spill that's going to cause a drain on your forces, and you might not have the population to conduct the inspections that you did before. Or you might have a pandemic where you want to limit the interaction between your inspectors and the boats. So now if I know the barge is most at risk for a marine safety issue, I can prioritize those and maybe make alternative arrangements for the barges that are less likely. Another project we did here at the center was titled Machine Learning Platforms to Improve Coast Guard Tools. This project used IBM Watson speech-to-text technology to analyze Rescue 21 audio files. The researchers used a pre-trained speech-to-text model to interpret Rescue 21 dialogue, and the results were promising, but this project faced unique challenges to the unique maritime dialogue. Since the model was previously trained using audio files not specific to the maritime domain, the accuracy for the Rescue 21 audio files suffered. Specific maritime phrases generated low accuracy, but the researchers determined that if they retrained that model using maritime specific audio files, that performance could improve significantly. And this could prove to be a technology to be very helpful for watchstanders trying to decipher these Rescue 21 transmissions in real time. And then finally, I want to talk about a project that's currently ongoing here at the center titled Artificial Intelligence, Machine Learning for Computer Imagery and Sensor Data. This project is ongoing and it has two main objectives. The first aims to extract actionable target information from Coast Guard video and sensor data sources using AI. The goal is to help the watchstander overcome the abundance of information being received by all the edge sensors and provide recommendations on the targets that should be focused on. The second objective of this project is to determine the infrastructure required for the AI to be securely and effectively integrated into current Coast Guard watchstander systems. This objective is heavily focused on AI sustainment because the technology cannot safely and efficiently be integrated into Coast Guard. It can't be safely and efficiently integrated into Coast Guard's secure architecture. It's not going to be reasonably used by the watchstander. So all of these projects really help with what you described before, is that heavy lift to really just let the watchstander do their job the most efficient way possible.
Yeah, no, thanks for that, Rusty. And it's interesting as you start to say, how do we integrate those? And it's clear that we're looking to provide those types of efforts to provide information back to our users, kind of to the humans. So Jared, I'd like to turn to you. Could you tell us about that human-machine interface, human-machine teaming, and how do we ensure that we're presenting kind of the best info to the users and doing so in the best way possible?
Yeah, absolutely. And I'll start off by defining human-machine interface, which HMI is really about how a user or operator connects with a machine, system, or device. Some common HMI devices you might all be quite familiar with, touchscreens or keyboards. So how do we know that that when we have information being presented on those interfaces, that it's really that necessary key information that an operator needs? Well, we're going to build confidence in that information while we're developing those interfaces by going through a user-centered design process. So where we're going to start there is basically first we have to understand the task that's going to be completed, as well as what are the user needs in order to successfully complete this task. So we may gather that information by either interviewing end users, those individuals that will actually be using the products we're developing that have an HMI component to them. So surveying them, interviewing them, basically getting that initial information, any relevant documents that are based on the task, if there's any task procedure documents, we're going to get that information so that we can develop an initial prototype. Once we have an initial prototype, then we're able to start some usability testing. So we might engage in formative usability testing, where in that case, we're really interested in getting end user feedback to help improve those HMI products. So in that case, really we're trying to diagnose issues where basically there's going to be any type of issue that's in the interface or the user interaction with the HMI device. And really, if the HMI device is also powered by AI, then you might include some additional metrics such as predictability, reliance, as well as trust.
Yeah, no, that's fascinating. Yeah, I want to come back to the trust. You both talked about a lot of kind of different areas where we'll use AI. And I think that speaks to our mission sets and our roles in the Coast Guard as a public safety agency with search and rescue, as a regulatory agency, as a member of the intel community, as a law enforcement agency. You know, it's clear that we need to be able to trust these systems. I mean, so Jared, I mean, to what extent really, you know, is trust a factor? How do we get at that?
Oh, absolutely, yes. So trust is critically important. In fact, I would say that well-calibrated trust is really important to the human and AI teaming. So trust has previously been defined as the attitude that an agent, in this case, we're going to be talking about AI systems, that basically these agents will help achieve an individual's goals in a situation characterized by uncertainty and vulnerability. So what's important here is that trust should not be blind, but basically directly proportional to how reliable the AI system is. So mistrust is appropriate sometimes. It's really based on when an AI system is not reliable, mistrust should occur. The issue arises when a user or operator is going to have more of a bias where they might have distrust or overtrust. So distrust can actually result in poor acceptance of the system or under utility of the system, whereas overtrust can have basically a kind of a over-reliance on the AI system. So with that being said, trust isn't necessarily a single state, but a user or operator may provide a lot of trust based on certain tasks for that AI system, whereas they're kind of withholding some of that trust on other types of tasks. But the key here is really to improve task performance, which is why we're integrating AI into the task, is that AI is better at certain tasks than humans. So we really need to allow the AI to tackle the more challenging, difficult aspects of the task that AI is good at, and allow the humans to be focused front and center on the tasks that humans are best at completing. So yeah, with that, I would just say that we really need to just have an appropriate amount of offloading those specific tasks to AI that which warrant an amount of trust that is correct for the AI's ability to successfully complete those tasks.
Got it.
Yeah.
And Rusty, I'm curious how, if you could quickly kind of go through how you and the teams are kind of working this trust into the products.
So typically, I think to Jared's point, the watchstander is ultimately the one that's consuming the information, and for them to use it, they have to trust it or believe that it's accurate. And a lot of times, we describe AI as a black box. So we don't see how it arrives at the answer it arrives at. And so the trust is sometimes developed over time when it's repeatedly correct. And so as the programmer, we rely on metrics to determine how well our AI system is doing. And three of the most common ones, one of which is pretty self-explanatory, is the overall accuracy of the algorithm. But the other two are precision and recall, are probably two of the more well-known metrics for AI. If I'm classifying something, as let's say I'm doing image recognition, so I'm doing, is it a cat or is it not a cat? If we're talking about precision, if my AI identifies something as a cat, how confident can I be that it was accurate in that decision? So that's our precision. And then out of all the cats I gave the program, how many of it did it correctly identify? That would be your recall. And so what you're looking for is something with high accuracy, high precision, high recall, and that's going to be something that's a pretty good algorithm and is going to generate trust upon your watchstander. So how do we do that? Well, when we're creating the AI, we're going to take data that's from the population we ultimately want to use it on, and we're going to divide that data into 2 or 3 sets, depending on what algorithm we're using. And so we have a testing set, which is used to create the AI, and then we have a training set which we use to create the AI, and then ultimately a testing set which we use to test it, as you would expect. And that testing set is never shown to the AI and not used to develop it. So that's where you get that pure metric of how well it's really going to do, or hope it's going to do in the real world. And so that's where the AI really is kind of a good, you can develop the trust in that, is because your final metric is on something that's never seen before and it wasn't developed on. And so if it does well there and performs well there, you can reasonably expect that it's going to perform well and similarly in the real world.
Well, let me kind of jump in addition to the technical, and we may be tight on time here, but there, again, I think back to our different roles, and I'll think between a member of the intel community and a law enforcement agency and a public safety agency, like we're really dependent on public trust. It seems that we need to be very careful about how we use data and how we use AI. Kind of what ethical concerns do you grapple with, or what guidelines kind of guide the research?
Sure. AI has somewhat, in recent times, gotten kind of a black eye in terms of public trust. And, we have to have trust between the public we serve. The Coast Guard is a public-facing service, but we also have highly classified systems. And we know from stories that AI has the potential to violate privacy laws. It can produce unethical results, and it can fail to be equitable across all demographics. And so it's something we grapple with here is, how can we be ethical with the data we grab, or which we're using, and how do we make sure that the results that are producing are not violating any ethical guidelines? And so here at the center, we make sure we're stringent to follow all DoD and DHS ethical guidelines. And we're really big on just maintaining that public faith, that public trust, that nothing nefarious is happening behind the scenes.
Got it. Not that I'm biased, we'll give humans the last word. Jared, closing thoughts?
Yeah, just kind of branching off of the ethics. It's really important that as we continue to develop AI human teaming, that we continue to develop user-centered AI guidance that incorporates those ethical standards as we go into the future.
Yeah. That's a great point. I think that's the end of the panel discussion, but I think there are some questions in the chat. So Beth and Corinne, we'll turn it back to you.
So Commander, I'll go ahead and read the first question, and the first question is for the unmanned team. So the question is, do you test USB and UUV with acoustic sensors? Did you consider option of acoustic sensor application for surface vessel detection?
Yeah, it's a great question. I know in the past, the R&D Center has done some acoustic testing. Long time ago, actually, maybe up to 30 years ago, we did some acoustic buoy testing down in the Gulf of Mexico. Acoustic sensors are great. There is some difficulty with target characterization to determine if it's a bad target or a good target. But we're definitely interested in that technology, and we have tested it in the past on our unmanned systems.
And there's, I think, a current project in conjunction with the Naval Research Lab and DHS S&T that is also looking at acoustic for this vessel detection.
Excellent.
Great. The other question here is for you guys again. Speaking of autonomy, perception, and supervisory control of engineering systems, how lashed up is the Coast Guard with the Navy's Ghost Overlord program?
I'm not sure what the technical definition of lashed up is. We work closely with our DoD partners. We've been working with them for a long time, especially in unmanned systems. We've done several joint efforts with the Office of Naval Research, which I believe is the lead on the Ghost Overlord currently, or maybe it's DARPA. But no, we're definitely following the advancements. The DoD is definitely making heavy investments and definitely leading the charge when it comes to unmanned systems. I think the challenge for the Coast Guard is to, determine exactly what the applications are for the Coast Guard and how we can leverage the DoD's great work in this area. That's something?
Agree.
So the next one is not really a question, but an offer of some technology on real-time video stream clarification and some work they're doing to move towards LiDAR technology, which is obviously an area of interest, and we've dabbled in that as well. But so I think that's it for the questions that I can see. Certainly, if the audience have questions and epiphanies along the way, oh, I'm sorry, I missed out. We have one. Are you interested in partnering with the DoD national laboratories for some of these technologies, especially AI/ML, UAS systems? Yeah, absolutely. So yeah, reach out to us and we'll make a connection. We are very heavily leveraged with the National Research Enterprise, and working with DOE is absolutely huge. I just want to say again that if you have any epiphanies along the way and questions for us afterwards, feel free to reach out to us. I have a slide here that has the contact information for our partnership director, but clearly we are a very small organization and we can't do the kinds of work that many of you are doing in your agency. So we look forward to your help in solving some of the Coast Guard challenges and maybe collaboration on solving some mutual challenges. So I think that's all we have for today. Thank you very much for joining us in this webinar, and thank you again to Beth and her team for allowing us to give you a glimpse into a little what we do here in New London, Connecticut. Over.
Yeah.